Welcome to the next part of the video about integration by parts. Okay, now let's continue with more examples. First example is integral of natural log x over x squared dx. So, as we did in the previous video, we used the ILATE rule to help us to choose the right u. Okay, so first let's write this as 1 over x squared times natural log x dx. This expression is a rational function which is an algebraic expression, and natural log x is a log function. In the ILATE, the L comes first before A, so we choose natural log x as our u. So use u equals natural log x, and from there we have the u equals 1 over x dx. Now the rest, if we take out this natural log x, then we have 1 over x squared dx. That serves as our dv. So dv is 1 over x squared dx. For this dv, what is our u? What is our v? Basically, the v will be the antiderivative or the integral of 1 over x squared. And you can check that the v must be minus 1 over x. How we can verify this? We can verify by simply taking the derivative of this and show that it is indeed equals 1 over x squared. Okay, with this setup, we are ready to compute the integral. So let me remind you that integration by parts says integral of uv equals, integral of u dv is equal to uv minus integral of v du. Alright, now our u is natural log x, the v is minus 1 over x. Okay, again we need to substitute this minus 1 over x to the v. 2 minus becomes a plus, so we can write this as plus 1 over x du. That's our du. 1 over x squared, 1 over x dx. So let's rearrange. Let's rewrite this expression as minus natural log x over x plus integral of 1 over x squared dx. Well, basically we have computed this integral of 1 over x squared before here. We know from this that the integral of 1 over x squared is minus 1 over x. So we have minus 1 over x plus constant. Alright, let's continue with the next example. Now we want to compute the integral of e to the t sine t dt. Again, let's use the ILATE rule. First, we know that this is an exponential expression and that sine t is a trigonometric. T comes before e, so choose sine t as our u. u equals sine t. Therefore, the u is cosine t dt. Now the rest, which is e to the t dt, is our dv. So now the v is e to the t. Okay, so integral of u dv is uv minus integral of v du. U is sine t, v is e to the t minus integral of v, e to the t, and du is cosine t dt. Well, let me write this as e to the t sine t dt. Well, it seems we cannot compute this integral. We don't know how to integrate this. I mean, usually after we apply the integration by parts, then everything is working out. So in this case, we need to apply integration by parts twice. So again, we need to use integration by parts to integrate this expression. By the same argument, we choose u equals cosine t, du is minus sine t dt, and dv is e to the t dt. Therefore, the v is e to the t. Okay, let's continue. So here we copy sine t e to the t, and then we apply integration by parts for that integral. So the same as we usually do, we have u times v cosine t e to the t minus integral of v du, e to the t, and then du is, I'm sorry, this should be just sine t. No, that's right. So du is, okay, du is minus sine t, and we have two minus here, so we can make it into a plus. Plus sine t dt. So let's write this as e to the t sine t minus e to the t cosine t minus integral of e to the t sine t dt. Well, it seems we have another integral. So how we can deal with that? It seems we can, if we use integration by parts, we will do this forever. Okay, so what do you think? So remember that the left hand side of this expression is e to the t sine t dt, which is exactly the same as this expression. So in order to solve for this integral, we need to collect all similar terms. It means we need to move this expression to the left hand side. Okay, let's move that expression to the left hand side. So we have e to the t sine t dt plus the same expression equals e to the t sine t minus e to the t cosine t. Now we have two kinds of this integral, so twice of integral e to the t sine t dt is equal to, we can factor e to the t out, okay. Now we can solve for the integral that we are looking for. So by dividing both sides with 2, we have the integral of e to the t sine t dt is equal 1/2 e to the t sine t minus cosine t. And since we are looking for the general antiderivative, then we need to always add a constant there. Okay, let's continue with a problem where the Eilert rule does not help us. Okay, so this expression, all are algebraic expressions, so the Eilert rule cannot help us to find the correct u. And here it's kind of, you need to do some experiments to find out which u is the best u, which u is the one that make this integration by parts works. In this case, surprisingly, if we do the following, so let's say we split this into r squared times r over that one dr. Okay. So here I claim that if I choose u equals r squared and the v equals to that, to the rest, then it will work out. Let's see. So choose u equals r squared, then the u is 2r dr, and choose dv to be r over square root 4 plus r squared dr. So now to find the v, we need to somehow integrate this. Okay, let's integrate that. Unfortunately, the integration is not straightforward. We need to use substitution rule here. Let's choose t equals 4 plus r squared dt is 2r dr. So the integral can be written as integral of half of 1 over square root of t dt. Okay, I will not explain in detail why this is true. Just check by yourself and convince yourself that it is indeed true. So if we rewrite in this way, so you can also write this as t to the negative 1/2. Then the v will be, so raise, when add 1 to the power, to the exponent. So actually that's all. That's our v. So the v, we need to put back t equals 4 plus r squared. So the v is square root of 4 plus r squared. Okay, now we are ready to use integration by parts. So the integral is equal to uv. U is r times square root of 4 plus r squared minus integral of v du, square root of 4 plus r squared, and the u is r over square root 4 plus r squared dr. So we have r times square root of 4 plus r squared minus integral of r dr. Therefore, we have r times 4 plus r squared minus half r squared plus a constant. Okay, and that's all for now. The second part of integration by parts. If you have any question, please drop any comments on the comment section below. Thank you for watching. See you on the next video.